G'day viewers. In this segment we'll talk about protocols and layering, and this is the most important idea there is for the structuring of networks. Okay, so networks need some form of modularity to manage all of their complexity. If you think about it, there are many different functions that you know exist in networks, and I've listed some here. Setting up all kinds of connections, finding the path through the network, reliability, all sorts of things to do with how fast you can send information depending on how many users there are and what network you're going through, security, management of the network so that you can easily add new hosts as it changes, and so forth. That's a lot of complexity. All of this, by the way, underlies the simple action of clicking and getting a web page back. So there's a lot of mechanism underneath to make that happen. Well, what we need is some form of modularity which will help us manage that complexity and allow us to reuse a lot of network functionality across many different settings. That is exactly what protocols and layering give us. Protocols and layering are the main structuring methods which are used to divide up the functionality of networks. So the way protocols and layering work is that each instance of a protocol, now you might think of this just as an object being an instance of a class, for example, it talks virtually to its peer protocol instance, which is on a different host elsewhere in the network. But the catch is, to talk virtually to that peer instance, the protocol is only allowed to use the services of a lower layer protocol on the same host. That all sounds a little mysterious maybe, so let me just try and draw a diagram to explain that. Okay, so let's see, here is a protocol instance. I'll write X to mean this is an instance of protocol X. Now, this protocol instance wants to talk to another protocol instance, X, on some other machine. To do that, it will use the rules of protocol X. So it will only exchange messages of protocol X and so forth. But I've dotted this line because there's no direct communication path between here. These are on different machines, these protocols. So how do they talk? They use the services of a lower layer protocol, in this case protocol Y. And protocol Y is similarly going to virtually talk to its peer, an instance of protocol Y on another machine using protocol Y. So X will locally on a machine use only the services of Y. Let me clean this up. So here's maybe a little bit of a clear diagram. What you should take away from this is that, so here's one host, by the way, if I just draw here, node 1, here's another host, node 2. So on this diagram, the layering is happening vertically as each protocol instance talks to the lower layer protocol instance, and the lower layer talks back to the upper layer when things are received from the other side. The protocols are designed horizontally. They're really specifying the form of interconnection between the two different systems. Of course, I still haven't really gotten to the bottom of this picture because we don't know how protocol Y really communicates. We see the virtual communication, but what's going on? Well, this is what's going on. The same thing happens again. The protocol Y communicates using the lower layer protocol. And when you do all of that, you get what's called a protocol stack. So here is a protocol stack. And here it's just listed layer 5 through 4, 3, 2, 1, down to the bottom. What's going to happen at the bottom? Well, at the bottom where it's labeled physical medium, this is really just a wire, or something like a wire, such as a fiber optic cable. This is the medium which carries whatever message as electrical signals from one side to the other. And then layer 1 is going to interpret that as a message. So by acting in this form, we've got a higher layer protocol, such as layer 5, being able to virtually communicate with its peer instance here without really knowing what's going on anywhere below layer 4. Well, protocols and layering are everywhere. You've probably heard of many different protocols, even if you didn't realize they were protocols. I'm thinking of things like TCP/IP, 802.11, Ethernet, HTTP, SSL, DNS, and many, many more, some of which we'll come across in this course. They're all protocols. We can even, just to show you how some of these things fit together, let me draw you an example protocol stack. And for this example, we'll choose a web browser on your host, say, and let's just assume that you're wirelessly connected to the internet. Okay, so now let's see, here would be your browser. That's really an application that's using the network. Now the browser, well, if it's a web browser, I happen to know that the web protocol is HTTP. Doesn't matter if you don't know this, we're going to cover all of these protocols by the end. The browser implementation will actually often include an implementation of HTTP. HTTP in turn runs on top of TCP/IP. These are the common internet protocols. And if you're on a wireless host, this TCP/IP will be running on 802.11. And then the wire comes out of here. I'll draw it as a wire, but in this case, the link really is wireless, so there would be no physical wire. But we can still draw it like this to show the connectivity. Here we are. I've cleaned it up once again. So this is the protocol stack that would be used for this particular instance. Okay, well, we're not quite done with protocols yet. There's still more mechanism that I want to tell you about. We said that protocols are layered one on top of the other, but we didn't really talk about how this layering is manifest or implemented. Well, encapsulation is the mechanism that's used to affect protocol layering. So the way it works here is that the lower layer wraps all of the higher layer content. It's going to have to add its own information, control information for delivery throughout the network. To understand how this really works, the analogy that we'll use here is that of sending a letter through the postal system. What you do is you write your letter, good old-fashioned letter, you write it with a pen, then you seal it in an envelope. The envelope is like the lower layer, a header information. It contains all of the addressing and so forth when you pass it to the post office in that form. The post office only then needs to use the lower layer information on the envelope to get the letter to the other side. And at the other side, the envelope is extracted. The letter is extracted when you open the envelope. Actually, there are probably even other lower layer protocols in here. Letters going to the same destination may be all bundled together so that they can be routed, in an airplane or a truck all at once and so forth. So this is what's going on with encapsulation. We can draw some pictures to show you what would happen with our example protocol stack here if we send messages through it. So let's see what happens. Well, at the top, HTTP, we're just going to start with a message. Okay, now, HTTP will pass it down to the lower layer. What will happen at the TCP layer? Well, here is the HTTP message. The TCP layer will add, well, actually, I should draw it like this. It will wrap it and add its own control information at the top. It'll then pass it down to the IP layer. Here that blob is. What will happen? The IP layer will wrap it and add its own header. That will then pass it down, and guess what will happen again? There it is. The 802.11 layer will wrap it and add its own header. Wow, this is a little tricky to draw boxes inside boxes, so I'm going to clean that up for you. And here you are. Look carefully at all of those different boxes. I omitted all of the inside detail just because it was too much for me to draw. But you can see that messages on the wire begin to look more and more like an onion. And that in fact the lower layers are outermost. You might think the higher layers should be outermost, but the lower layers are outermost because of the way it's constructed going down that protocol stack. Here's the same view as I've shown both the sending and the receiving protocol stack. So we go down that protocol stack and you can see, what happened as we expected here. Now, this is the interesting bit. This is what actually you would see if you were to look on the wire of a network and to see a message going by. It would be like this. And this is the beginning. This is the start over here. On the receiving side, you can simply go through the reverse process. The 802.11 layer looks inside it and extracts this bit here, and sends this up to the higher layer and so forth. And we continue. So that's encapsulation. In fact, actually, normally we'll draw encapsulation much more simply. I showed it as really drawing a layer around the higher layer payload to encapsulate it, but often encapsulation will simply proceed by having each layer add its own control information to the front. So TCP there will add a layer in front of HTTP, IP will add a layer in front of TCP, and so forth. And 802.11 will add this layer in front. This is a simple form of layering, just adding a header in front, but this is often what's used in practice for many of the protocols we'll look at. In fact, this is just how we'll think of it. Layering practice can be more complicated than this. For instance, you might have trailers as well as headers. Trailers are information, control information, which is added at the end. And the information that's in the middle may be transformed in reversible ways, such as encryption or compression, such that you might not be able to see it literally, instead of simply leaving it alone. But we can just ignore this for now and think in terms of our simple model here. And actually there's even more complications. Sometimes you might use, what's called segmentation and reassembly. This is when a long message from a higher layer is divided into many smaller shorter messages at the lower layer, just because the longer message didn't fit through the network as is. But wait, there's more. There's one other thing I've got to tell you about layering, and then we're mostly done with the mechanics of layering, and we can see how what we get out of layering. Okay, well, when a packet comes in down here at the lower layer, we've got to work out what protocol instances are inside it. Your computer is probably running many different protocols that are used by many different applications. Now, if what came in is really part of our web application, we knew from before the protocol stack was this. It was, let's say it was Ethernet, TCP, and HTTP. But how do we know to follow this path through the graph and not, for instance, this other path, Ethernet, IP, UDP, DNS? This other path is a real path. It's something that's used for DNS traffic to translate host names to IP addresses. Well, how are we going to do this? Think about it for a moment and see if you can work out the answer. Okay, you ready? Well, this is what we would do. In fact, what must happen is that each layer includes inside it some control information to identify the higher layer. So as the packet comes in here, we know it's Ethernet here simply because Ethernet, all messages on this network are Ethernet if it's an Ethernet network, say. But the Ethernet header will have a little bit of information that says go this way to IP. In Ethernet, this is actually called the ether type value. Now, then as IP processes, IP will look inside its control information. There'll be a little bit of information. It's actually the IP protocol field, which says go this way to TCP. And inside the TCP header, there'll be a port number, which says go this way, which will happen to be HTTP. This information in each protocol layer is what's called a demultiplexing key, because it helps us undo the multiplexing and go back up the right route. Okay, well now let's see how we can gain some advantages from layering, now that we've gone over its mechanics. Layering, the key advantage it gives us is information hiding, and through that reuse. So imagine we have our browser and server application here, our good old web browser. You could run it on a protocol stack like this. Well, all the browser knows is that it's talking to HTTP here. But let's say you happen to run HTTP on the protocol stack TCP, IP, and Ethernet. Okay, Ethernet is a typical wired enterprise network. You could similarly run the same web browser on a different protocol stack. Let's just say we want to run it on TCP, IP, and 802.11 because this is a wireless host. Wonderful. The web browser doesn't actually either know or care what it's running on at the lower layer, and this is a tremendous advantage because it would be terrible if we had to write our web browser differently depending on all of the details of the protocol stack. By hiding information, we're getting a lot of powerful reuse out of it. There it is cleaned up. Oops, I chose the sides differently. Doesn't matter. And we can also gain further advantages. You can use this information hiding to interconnect different kinds of systems. So imagine over here we have the browser. It happens to be running on an 802.11 network. Well, the server, that happens to be running on an Ethernet network. Doesn't matter with our protocol layering system. This is what we can do. Here, we'll have the 802.11. It must talk to a peer 802.11 box. And similarly an IP layer. So we will use this 802.11 box to terminate the packet, the 802.11 layer, pass it up to the IP layer, which can then pass it across, or keep it within the IP layer is maybe a better thing to say, and pass it down to an Ethernet layer. In the same way that over here we passed an IP packet down to an 802.11 layer. This Ethernet layer is then able to virtually communicate with another Ethernet layer protocol. And everything is okay. We've managed, by using protocols and layering, to interconnect web browsers and servers running on different kinds of networking technology. So this is what protocol layering is all about as a means to connect things. Note that to do that, we needed to have something like a single layer here which provided connectivity all of the way across. And this is what IP does frequently in the internet. It's the basis for being able to connect everything with different kinds of media type below and different kinds of applications and protocols above. Here's that same picture cleaned up a little bit. What I've done also is down here, I've drawn a picture just of the message as it would appear on the network. You can see we started with the HTTP message and we added these headers. Now I've shown in pink here, this portion is the portion which is not touched as it's carried across the network. I've left the IP piece unshaded a bit because the IP processing happens in here, so the IP control information front may be altered. And similarly, we can see as we go across actually, this 802.11 will be taken off and this Ethernet portion here will be added as we go on the other side. But all of the information in the middle that we cared about, the TCP and HTTP, will be passed unaltered. And this is what is providing us with virtual communication between the browser here and the server here. So that's protocols and layering. Just to round out our notion of protocols and layering, I'll tell you that there are some disadvantages to layering. It's not all roses. Here are two disadvantages. The first disadvantage is that layering, adding more modularity, adds a little bit of overhead. If we knew, for instance, that our protocol stack went HTTP, TCP, IP, and Ethernet, maybe we could devise a custom header which had all of the necessary functions in one, and it would be shorter. So we definitely lose a little bit of efficiency. Often this is a minor concern. If you're thinking of large packets, the overhead of layering is small, it's some small number of percent. Now, on the other hand, so that was this, adding overhead. A bigger concern probably is that layering hides information. We said that our web browser now doesn't know whether it's running over a wired or a wireless network. Well, you know, that allows us to run the application, it's true, but your application might care whether it's running over a wired or a wireless network, because really they're quite different. On a wireless network, the bandwidth is much more variable and you could be changing locations all of the time. This is something that an application would like to know. So information hiding is a disadvantage of layering. Okay, but the point is, now you know about protocols and layering, the key mechanism that's used to structure computer networks.